Now I want to talk about standard limits. You realize that when we wanted to find the limit of the function 2x plus 3 as x approaches 4, we plugged in values that tend to be closer to 4 from both left and right hand side to obtain its limit to be equal to 11. Now if we are asked to find limit of a function, we cannot follow this procedure of making tables and checking the limit every time, as it will be very difficult to calculate the various values of f. Hence, we assume the following results as standard formula. So the first one, which is the limit of constant functions. Now, what are constant functions? A constant function is a function in the form f of x equals k, where k is a constant. If k is a constant, then the limit of f of x as x approaches a is equal to k. Remember, f of x is k, so we are going to have limits of k as x approaches a equals k, where a is any value. So far as the limit function is a constant, whatever value x is approaching is just going to be the function itself, which is the constant. So the rule is that the limit of a constant function is the constant itself. So if you have limit of 4 as x approaches 20, this is equal to 4. If you have limit of 4 and it approaches 30, it's still 4. It does not matter the value it is approaching. Once this is a constant, then its limit is going to be what? The constant. If you have limit of 9 as x approaches infinity, this still equals 9 because 9 is a constant. Another one is limit of the function. S to the power k. Now, if you have lim of x to the power k as x approach any value e, then this equals a to the power k. What we are saying is that if you have x to a power which is k and x approaches a and we are asked to find this limit, then the limit is basically a to the power what? K. The value that x is approaching to the power k. For instance, if you have limit of x to the power 5 as x approaches 2, then this is going to be equal to, remember, we just want to substitute this value 2 into the function. So you're going to have 2 to the power what? 5. So you have limit of x to the power 10 as x approaches -1. Then this is going to be equal to -1 to the power 10. Third one, limit of the function x. That is very simple. That is very simple, right? I guess you know. So if you have limit of x as x approaches the value e, then what is going to be the answer? Alright, I guess you've given the correct answer. It's going to be e because you will just substitute a into the function. For instance, if you have limit of x as x approaches 5, then this is going to be 5. And what we've done is that we've plugged in the value 5 into the function x. The fourth one I'm going to talk about is the limit of the function in the form kx, where k is a constant and of course is a coefficient. So we could have something like this: limit of kx as x approaches e, and this is going to give us k a, because k itself is a coefficient. And so we could have also represented this as this. We want to bring k outside, so we are going to have k going to multiply limit of x as x approaches e. And I guess you know this itself is e, right? That's what we've done here. This itself is e, so it's just going to be basically k times e, right? So we can have something like this: limit of 3x as x approaches 4. So we are going to put 4 into the function, and then we are going to have 3 times 4, which equals 12. Now let's try to solve some problems on limit. So let's say we have limit x plus 2 and x is approaching 3. Let's also take lim x squared minus 1 as x approaches 3. Let's also take limit x squared minus 4x plus 2 and ask as x approaches 2. Alright, so I'm going to do these two, the first one and the second one, and then I'll leave you to do these. Right? So let's start with the first one. We know that this is going to be what? 3 plus 2, and this equals what? 5. We substituted the value 3 into the function. With the second one, you're going to have 3 squared minus 1, and that equals 9 minus 1, and this equals 8. So I want you to try your hands on this one. And so now let's proceed with the standard limit. The fifth one that I'm going to talk about is the functions in the form f of x times g of x. So we are having two functions, f of x, and it is multiplying another function, g of x. How do we find the limit of these functions? Now, if we have limit of f of x times g of x as x approaches a, then this is the same as limit of f of x as x approaches a times limit of g of x as x approaches a. And so look at something. This is going to be the same as what? F of a times g of a. I hope you know f of a. If you have a function f of x equals 3x, then if you are to find f of 2, it's just going to be what? Equal to 3 times 2, right? Which equals 6. And so remember, if you are to find the limit of 3x as x approaches 2, it's going to be what? 3 times 2. What we have basically done is that we have found the image, which is f of 2 of the function 3x. So now, if you are to consider this side, limit of f of x as x approaches a, which is basically finding f of a. So that is what we are having here. And then times limit of g of x as x approaches a, which is basically finding the image gene of a. And so we are having f of a times gene of a as the answer. So let's take a practical example on this. Now let's say we have x plus 3 times x squared minus 5, and we are to find the limit as x approaches 2. Now, this is how we can write it. We can also write it as what? Limit of x plus 3 as x approaches 2 times limit of x squared minus 5 as x approaches 2. This is going to be what? 2 plus 3 times 4 minus 5. This is going to be 5. This is going to be 4 minus 5 is negative 1. And the answer is going to be negative 5. So try your hands on this. Limit of x squared minus 3 x plus 5 as x approaches 9. So the sixth standard limit I'm going to talk about is the limit of rational functions. So if we have a function f of x, and this function is actually a rational function which equals g of x over h of x, where h of x can never be equal to 0. Once it is 0, it makes this undefined and therefore it's not rational. The limit of this rational function f of x, which is expressed in this format g of x over h of x, is going to be limit of g of x as x approaches a, all over limit of h of x as x approaches e, provided either limit of what h of x is not 0, because when it is 0 it is going to make it undefined and the limit will not exist. Any number divided by 0 is undefined. And so these limits exist provided either h of x, the limit of h of x, is not 0 or both of them is not 0. Now, in finding limits of rational functions, you must make sure that the rational function is in its simplest form. So, we have to find the limit of the function x squared minus 1 all over x plus 1 as x approaches negative 1. Now, the function itself is a rational function because we are having g of x over each of x. This is a function over another function. And of course, h of x is not equal to 0. And so let's try to find the limit. Now we learned that this can be written as limit of x squared minus 1 as x approaches negative 1 all over limit of x plus 1 as x approaches negative 1. Now let's look at something. If you are to plug in negative 1 into this function, we are going to have negative 1 squared, which is positive 1, minus 1, and the numerator is going to be 0. If you are to plug negative 1 to this function also, we are going to have negative 1 plus 1, and that equals 0. And 0 divided by 0 is undefined. And so this means that the limit does not exist. However, it was a calculation error. Remember I told you with rational functions, if you want to find the limit, we must ensure that the rational function itself is in its simplest form. And so let's come back to the function. We realize that x squared minus 1 can be rewritten as x plus 1, x minus 1. So if you are to expand this, you obtain this. And so that is it. Remember, x squared minus 1 squared is what has been written as this. And so this is basically a difference of two squares. And so these are the factors x plus 1, x minus 1. So if we substitute back to the function, we are going to have x plus 1, x minus 1 all over x plus 1. And we have to find the limit as x approaches negative 1 of this whole function. Now you realize that x plus 1 can cancel this x plus 1. And so we are going to have limits as x approaches negative 1 of the function x minus 1. And so if you are to plug in the value negative 1, we're going to have negative 1 minus 1, and this equals negative 2. And so the limit of this function is actually equal to negative 2. Now, I want to show you the calculator trick that you can use to solve this. if it was a multiple choice question. So pick your calculator. Now the question says that you have to find the limit of the function x squared minus 1 all over x plus 1 as x approaches negative 1. So x actually is approaching negative 1. So we are going to pick a value that is close to negative 1, either from the left hand side or the right hand side. So this case, I want to pick from the left hand side. So let me go back so that we can illustrate it very well. So if we have 0 on the number line, negative 1 is here, then we have negative 2. And so we can pick a number that is close to negative 1 from this side, or a number that is close to negative 1 from this side. I want to pick from here. So that is negative 0.9999. So now let's go back and then pick our calculator. And then what we are going to do is that we are going to store a value as 0.099, the negative of it. So you are going to have negative 0.999. And then you are going to hit shift, and then there is a button here, RCL, which is the store. Then we store, and then we choose a variable that we want to store this value to. So we are going to store it as x. So x is here, we hit on. So now anytime the calculator sees the variable x, it's going to assign the value negative 0.99. So we go back to our question and then have it written on the calculator. So we have alpha x squared minus 1 all over alpha x plus 1, and then we hit the equal to button. And so we are having a value of negative 1.999, which is equivalent to negative 2. And so this is how you can actually calculate for the limit using your scientific calculator. Let's take another example. You're having limit of x squared minus 4 all over x minus 2 as x approaches 2. This can be rewritten as limit as x approaches 2 of the function x squared minus 4. X squared minus 4 can be rewritten as x squared minus 2 squared all over x minus 2, right? And so this is the same as limit as x approaches 2 of the function x squared minus 2 squared can be rewritten as x plus 2 x minus 2 all over x minus 2. And so these ones cancel out. And then we are having limit of x plus 2 as x approaches 2. And we're having 2 plus 2, and this equals 4. And so always make sure the rational function is in its simplest form. Let's take third question, and that is limit as x approaches 2 of the function x squared minus 7x plus 10 all over x squared minus 4. And so pause this video and try your hands on it. Alright, I guess you've had it correct. So let's start solving it together. So now we want to make sure that this is in its simplest form. So x squared minus 7x plus 10 can be factored. And then x squared minus 4 can also be factored, right? Let's factor the numerator. So you want to look for a number that when we add, we are going to obtain negative 7. And when we multiply, we are going to have 10, positive 10. And so those two numbers are negative 5 and negative 2. Negative 5 minus 2 is negative 7. Negative 5 times negative 2 is positive 10. So now we are going to have this equals limit as x approaches 2 of the function x squared minus 5x minus 2x plus 10 all over. This can also be rewritten as x squared minus 2 squared. And this equals limit as x approaches 2 of the function. Now in the numerator, if we factorize x out, we are going to have x minus 5. And here, if we factorize negative 2 out, we are going to have x minus 5. So we are having x times x minus 5 minus 2 times x minus 5. And then with the denominator, this is a difference of two squares, and so we are going to have x minus 2 x plus 2. This is also equal to limit as x approaches 2 x minus 2 x minus 5 all over x minus 2 x plus 2. And so x minus 2 cancel out. Then we have limit as x approaches 2 of the function x minus 5 over x plus 2. So now f of x, which is a rational function, is now in its simplest form, that is x minus 5 over x plus 2. So we have limit of x minus 5 over x plus 2 as x approaches 2. Now we learned that this is the same as limit of the function x minus 5 as x approaches 2 all over limit of the function x plus 2 as x approaches 2. And so when we plug in 2 into this function, we are going to have 2 minus 5. And then when we plug in 2 into this function, we are going to have 2 plus 2. And so we have 2 minus 5, that is negative 3, over 2 plus 2, which is 4. And so limit of the function x squared minus 7x plus 10 all over x squared minus 4 as x approaches 2 is equal to negative 3 on 4. This is an elective math class. You could have factored this one out directly. No need to use the normal procedure. You could have used your scientific calculator. So let's go to the scientific calculator. Alright, so you want to factorize the function x squared minus 7x plus 10. So we go to mode and we have 5 EQN, which means equations. And then now the equation we are talking about here, because of the power x squared, it means it is of the form ax squared. So we pick this. Now when you have the third degree, you pick the fourth one. This one we are going to pick the third one. So you have the third one. So now a is a coefficient of the variable to the power 2. And in this case, x squared is having a coefficient of what? 1. So we hit 1 and press on equal to. Now, b is a coefficient of the variable x to the power 1. And in this case, x to the power 1 is having a coefficient of what? Negative 7. So you have negative 7. And then c is a constant. C is a constant. And in this case, it is 10. So you write 10. And then we hit on equal to. And the answer is 5 and 2. So let's come back. We were having x equals 5 and x equals 2. So if you want to get the factors, it's going to be what? X minus 5 equals 0 and x minus 2 equals 0. These are the factors. So x minus 5, x minus 2. So you could have just written it like this and factored directly without using a normal procedure. Alright, so try your hands on this. You have to find the limit of 9 minus x. This is 9 all over 3 minus root of x as x approaches 9.